Hello, Geometry. Welcome to the last similar transformations. My learning targets, I can perform dilations and similarity transformations, and I can use perspective drawings in art. Hence our project. Okay, so here we go. Give coordinates, let's do our warm-up first. Give coordinates of a point twice as far from the origin along the ray from 0, 0. Okay, so if I want to go twice as far, 2 times, this is going to become 6, 10. Okay, so my original points, x, y, will go to 2x, 2y. All right, this is going to follow us through for the whole section. Here we go. Twice as far. Okay, of course, that y value there is not going to really help us much, but this is going to become -4, 0. Take a half times 2. You're going to get 1. Negative a half times 2 will be -1, because those diameters will cancel. How about this one? Ooh, typo. Okay, give coordinates of a point 1/2 as far from the origin along the ray from 0, 0. Okay, so we want to go half as far. So halfway to 6 would be 3. Halfway to -4 would be -2. So basically, the rule of thumb here will be half of x and half of y. How about this one? Again, 0, you don't see much happening there. This is going to be -7/2. Go ahead and leave it as a improper fraction, that's fine. Alright, so, a little activity. This is an activity in your book on page 402. So using graph paper, plot the points 1, 3 for A, 5, 3 for B, and 5, 1 for C, and then draw the triangle. Oh, look at that. I happen to have that right here. Okay, notice that I've got a glare, and I've got the upper light above me. Let me go turn, I guess we're doing okay right now. Now I'll turn that off, see if it helps. I just realized I did the last video with that glare, so I hope it wasn't bad. Getting the hang of this. I have to do videos at night. Alright, use the origin and draw OA, OB, and OC. And I'll do that in red. Okay? Okay, so O is at the origin, right here. Here's A, there's O. I'm just going to draw these points out. You'll see what's happening soon. It's kind of cool. Alright, I did exaggerate those lines, but I want it to be like that. Use a compass to mark a point D on OA. Oh, I do have a compass with me. At first I didn't have it. Okay, so we want it to be, so OA is equal to AD. Wait, what? Is equal to AD. So I've got to like double it. Okay, so I have this length. Alright, so I'm measuring out this length. So I've got to mark it. We're going to call that D. And then we're going to mark out E. Ooh, didn't make that long enough. And then mark out C. So hopefully you're watching this video so you know to make your lines really long. Okay. So this is E, right about there. And this would be F, right about here. Alright, so far so good. Now connect the points D, E, and F. Okay, to form the right angle. Obviously, I've got a slight issue right there. Draw conclusions. Measure AB, BC, DE, and EF, and calculate the ratios. All right, so AB we have to measure. It's about, say, 2.7. About 1.5. So 5 point, let's see here. It's really hard to see. About 5.1. About 2.6. Using the information, show that the two triangles are similar. Okay, so they should be both right triangles, but I see right away I have an error right here because D should probably be right there. I wonder if my compass moved. And since I doubled this length, this should have been just about double. And if I double this, I should have gotten 3. Double that. Yeah, this is just a mess. But in any case, what we've just drawn is a dilation, a scale drawing. And it is basically, it should be 2 times a ratio from 1 to 2, or you can say a dilation should have 2 over 1. Okay, because it's getting, the original is smaller than the larger, so it's got to be a bigger number than 1. Okay. In any case, what's even funnier is when I did this problem last time, I accidentally made DEF half the size, and I have no compass marks, so I'm not really sure how I even did that. Okay, so in any case, here we go. A dilation is a transformation that stretches or shrinks a figure to create a similar figure. A dilation is a type of similarity transformation. In a diagram, the figures is enlarged or reduced with respect to a fixed point called the center of dilation. So in this case, our center of dilation was the origin, O. The scale factor of a dilation is the ratio of the side length of the image to the corresponding side length of the original. Okay, so the scale factor of this should have been 1 to 2. Okay, should have been. As shown in the figures, the image. The center of dilation is 0, 0, because the scale factor, notice xy will go to kx, ky, where k is the scale factor. So if k is between 0 and 1, it's less than 1, it's a reduction. If k is greater than 1, it's an enlargement. Okay? Alrighty. So like taking a look at this, 6 is going to correspond to 3. So k is 6 over 3, which is 2 over 1. So this is our image, and this is our original. Alright, so yeah, it says right here, XYZ is the image of ABC, so this is our original. Okay, I prefer it when they put the original on the left side all the time, so it drives me crazy a little bit, but always pay attention to what they're saying up in the description, okay? Alrighty. The next one. Oh, look at this. I already have it drawn on my page. So why don't you pause this, draw out your quadrilateral, and draw this. So we're going to draw a dilation of a quadrilateral, hi buddy, ABCD with those vertices, and we're going to use a scale factor of 1.5 and label the image FGHJ. So F, yes, a quadrilateral is a four-sided shape. Good job, bud. FGHJ. Okay, so basically, this is my rule here. We're going to go from x to 1.5x, y to 1.5y. So we have to take each one of those values and multiply it by 1.5. So when we do that, well, half of 2 is 1, and then 2 times 1 is 2, so add them up, you get 3. So this should be 3, 3. And this will be, I should do this in a different color. And then when I graph it, it'll be a different color. So 3, 3. We're going to do this in red. So over 3, up 3. And that would be letter F. Okay, then we have the 0.63 over 6 up 3. That will be G. The next point will be 6, 0. And that will be H. And last but not least, J will be 0, negative 3. Okay, so now we're going to connect this. I almost feel like I probably shouldn't have used red. Maybe I should have used green. I don't know. Red seems like it always seems to be a reduction. But this is an enlargement. Okay. Now, one thing I want to show you, well, there's your final answer, and basically they're similar by side, side, side. But I'm going to show you something. I'm going to put a piece of patty paper. So I'll be giving you some patty paper if you need some. I'm going to tape it on so it doesn't move. And from the origin, I'm going to draw letters. Maybe I should do that. Of course, I don't have a highlighter. How come I don't have a highlighter in here? We'll do green now. From the origin to my original letters. What do you notice? Can you see that? This green line is going through both A and the image, both B and the image, C and the image. That one's kind of hard to see. And then D and the image. That's why I think it would be best to do this with a highlighter so you can see it over. Isn't that kind of cool? Okay. Oh, look at this. Example 2. Same thing. Draw a triangle with those vertices. Now we're going to go half. So we're going to get a little smaller here. So I already have the rule written down. And let's see. Here we go. Let's do this in red. What's half of 2 and 4? 1 and 2. Over 1 up 2. And I'm calling this DEF. Alright, 8, 4. That'll be 4, 2. So over 4 up 2. And this one will be 4, negative 2. Over 4 down 2. I'm going to draw my triangle. Yeah, so the only reason this video is long is because I'm actually drawing it, because we would be doing this together in class otherwise. And that is a scale reduction. Okay, it's 1/2 of it. Now, again, I'm going to take some tissue paper. I'm going to tape that on there. And I want you to see the dilation with the center at the origin. I'll just do this in green. So my original A through the origin. That sounds funky. Origin to B. And the origin to C. And what do you notice? It's going through also your reduced image. Pretty cool, huh? All right, last page. And I'm done with the chapter. Oh, look at this. I actually did draw this one out for you. So thought I'd help you out just a tiny bit. Okay, example 3. You're using a photo quality printer to enlarge a digital picture. The picture on the computer screen is 6 by 6. The printed image is 15 by 15. What is the scale factor of your enlargement? Okay, so here we go. Remember, you want to do the image to the original. So 15 to 6, divide both by 3, 5 to 2. So there it is. Remember, if we write it like this, since it's getting larger, you want to make sure this is greater than 1. So that's how I always remember it. If it's reduction, it would be turned around. It would be flipped over. All right, so you want to create a quadrilateral RSTU, similar to the quadrilateral ABCD. What are the coordinates of U? Okay, so we're missing a point here. So this is my original, and now we want it to go like this. So when you see something like this, write down the ordered pairs of your quadrilateral, and then write down the ordered pairs of what you have so far. What do you see happening here? 1 times what? 2 times what? 2 times what? 1 times what? Basically, it looks like we're taking each one of these and multiplying it by 3. So that's our scale factor. All right, so 5 times 3 is 15, and 3 times 3 is 9. Bad 5. D for donut. All right, so where would that be? Yeah, it'd be way out here. That was poor choice in graph, huh? 15 and 9, it'd be way out about here somewhere. Okay, all right. Well, in any case, here's our homework, and there's our Common Core standards, and I hope you have a very nice weekend. Stay warm and dry. Tomorrow should be better, but next 2 weeks are going to be kind of cold. Hang in there.